Om Swastiastu. Hello everyone, my name is Iwayan Kisendranata with last study number 005. Now I would like to give you an explanation about potential effect of population and climate change on global distribution of dengue fever. Let's start. There is increasing scientific interest in the potential effects on health of global climate change. One area that has received particular attention is the association between climate variation and vector-borne disease. Dengue fever is the most important viral vector-borne disease in the world. The disease affects hundreds of millions of people every year, and is transmitted predominantly by one species of mosquitoes, Aedes aegypti, which has adapted to living near areas of human habitation. It feeds during the day and prefers human beings to other animals. No effective vaccine or drug treatment for dengue fever is yet available, so management of the disease has relied on vector control measures, such as reduction of breeding sites and use of insecticides. Such measures have succeeded in eradicating mosquitoes in some regions, but have proved difficult to maintain in the long term. Mosquito-borne disease transmission is climate sensitive for several reasons. Mosquitoes require standing water to breathe, and a warm ambient temperature is critical to adult feeding behaviors and mortality, the rates of larval development, and speed of virus replication. If the climate is too cold, viral development is slow and mosquitoes are unlikely to survive long enough to become infectious. Although a suitable climate is necessary for disease transmission, other factors are needed for an epidemic to take place, including a source of infection, vector population, and a susceptible human population. Existing theoretical models of the potential effects of climate change on vector-borne disease do not account for social factors such as population increase or interaction between climate variables. Reuters and was to investigate the potential effects of global climate change on human health, and in particular on the transmissions of vector-borne disease, on the assumptions that other factors affecting dengue fever transmission remain the same. Reuters forecasts that climate change will contribute to a substantial increase in the number of people and proportion of global population at risk of dengue fever. The finding that the baseline distribution of dengue is well predicted on the basis of reported vector pressures is biologically credible. Humidity, defined as a vector pressures or specific humidity or humidity, is high only where rainfall and temperatures are high, and these are conditions that are conducive to breeding and survival of vector population and rapid replication of the virus. With a suitable climate, other factors, including a source of infections, vectors are and susceptible human population, will also need to be present for an epidemic to happen. Where and when dengue occurs in the future will therefore depend on diverse economic, social, and environmental factors. Spatial autocorrelation is likely to have increased the apparent significance of the result. However, the main results are likely to be conservative, since when we attempt to model residual spatial autocorrelation by including additional variables in the model, the population are increased. Furthermore, in this study, Reuters are mainly interested in applying the model to predict the effects of an incremental change in humidity, the margins of the present distribution of dengue fever. This prediction ought to be almost an effect by spatial autocorrelation, a model that predicts the current distribution with high cross-validation accuracy should continue to perform well when there are incremental changes to humidity as a result of climate change. That's all about my explanation. Thank you.